now.
Yeah, it's got a 360 view and microphone, it's all in there. I think we can probably go ahead and get started. If you didn't hear it before, I'm Becca. I'm with AGU's Media Relations Office, and we're here for our 1:30 roundtable with the USGS. Hear all kinds of exciting things: greenhouse gas emissions, critical minerals, and more. Like our other press events, this will be recorded and posted to YouTube later today. For press, slides, and any other materials that you might want to make available for them will be posted to the Press Information Exchange on AGU Connect. And the goal for this event, this event format, this roundtable, is really to have it be a little more conversational, a little bit less formal than the press event with everyone up on the stage. So once we're in the Q&A portion, feel free to just pop out questions. And yeah, I'd actually love for the reporters in the room to introduce yourselves too, just so we have a sense for who's here and to facilitate that friendly conversational atmosphere. Crystal, maybe? Yeah. Or do you want to start in this end of the room?
I'll start, yeah. I'm Jennifer Stephen. I am with Physics Today. Laura, who's also with Physics Today, will be here in a moment.
Hi everyone, I'm Crystal. I'm a freelance science journalist, writing for Life Science, and I review science news. Yeah. Reporter.
I'm Tim Wilson. I'm the senior science editor for EOS, so AGU's magazine.
I'm Romero Fun. I'm a reporter at Vox covering science and earth science in general.
Stacey Morgan, I'm an editor with The Conversation.
Thank you all for coming.
Yeah, great. So with that, I'll turn it over to our panelists.
Great. Well, hi, everybody. Thanks very much for coming. I'm Jeff Plumley. I'm the chief scientist of the USGS. So my job is to look out across the vast space of USGS science, and it's like being a kid in a candy store, seeing all the great work that we do. We have, do you want me to give a little bit of background about the USGS?
That's up to you.
So I call us an Earth System Science Agency, and we provide, we're not regulatory, we're not advocacy, we provide science, actionable science to inform policy decision-making from a wide range of folks, all the way from the public up to state, local, state, federal entities, and internationally as well. So we are very proud of our reputation for transdisciplinary science. We have, we look at so many different things. We look at mineral resources, energy resources, ecosystems, wildlife health, water resources, geospatial, remote sensing. We have the Landsat satellite. Let's see, am I covering natural hazards, or what you would probably traditionally view as the USGS natural hazards? Earthquakes, volcanoes, landslides, geomagnetic storms. And I think I've covered sort of the broad spectrum, but within that, we just do all sorts of many different things on providing our science on some of the wicked challenges that that the nation or the world are facing on a wide range of topics. So we have a bunch of really key scientists that are here today, that are going to give you some really interesting stories about the kind of work that they do. And these are just a small sample of the range of really cool science that the USGS does, and very important science as well. So with that, I will have folks introduce themselves.
I'll start. I'm Jane Hammerstrom. I'm a research geologist with USGS in Reston, Virginia, in the Geology, Energy, and Minerals Science Center.
Peter Warwick, research geologist as well, Energy and Minerals Mission Area, and the same science center as Jane in Reston, Virginia.
I'm Melissa Lombard. I'm a research hydrologist in the New England Water Science Center, and I'm located in New Hampshire.
And we will have one other scientist joining us, a part of our small, oh, there she is. I was just going to introduce you. Why don't you introduce yourself?
Oh, hi. I have a minute. I'm Dr. Sarah McBride. I'm a research social scientist with the Geologic Hazard Science Center. I specialize in studying people and their interface with earthquakes, landslides, and space weather.
And we're delighted to have Sarah here because a key aspect of our science is how we can actually communicate it to the people that need it the most. How do we go about doing our science? So we've always had a fairly small number of social scientists, from economics to risk communicators, but that's like a lot of agencies, we're having a very growing group of folks across different social science disciplines. So we're delighted to have Sarah here as well. So with that, what would you like to do? Oh, okay, we've got some slides.
Come on.
Yes.
Hi, I'm going to talk to you guys about Earth MRI. It's a really cool program. It stands for Earth Mapping Resources Initiative. And this kind of got started with an executive order in around 2017, when the USGS was directed to develop a critical minerals list for the United States. And so the critical minerals list has expanded to include 50 different critical minerals. And things are on that list mainly because of supply chain risks, things that might be vulnerable to supply disruption, things that are essential for manufacturing, and things that are essential for our national security. And if we didn't have those things, we'd be in trouble. So just an example of some of the things that are on the critical minerals list and what they're used for are in that bottom panel. And a lot of these things are elements you might have forgotten about from memorizing the periodic table when you were in high school. Things like neodymium, they're more like Jeopardy questions than things like copper and gold that are on people's minds all the time. So in order to try to look at where we have critical minerals in the US and where we might have them in the future, we started this Earth Mapping Resources Initiative. And it's a program to collect new geologic framework data so that we can really understand what we have and what we might have. So it's a partnership with the state geological surveys and other federal organizations, and in some cases with industry, to collect fundamental new data for the US. And so one of the things we're doing is getting new geologic map data, and we fund the state geological surveys to go out and collect new mapping data in critical areas. And so when we started, we had to figure out, well, where are the areas that might hold critical minerals? So this map that you see on the top, we developed 23 different broad mineral systems that could contain different kinds of deposits that contain critical minerals. That is not everything everywhere all at once, even though it looks like it. That was just our broad framework. We call them really broad focus areas. And then we start looking in those focus areas and working with the states to figure out where we need new data. So in addition to the mapping, we also collect new geophysical data, airborne radiometrics and airborne magnetic surveys, some electromagnetic surveys. We're also doing a lot of chemical analyses of rocks. So when the folks go out and do mapping, they send the rocks to us, and stream sediments that we analyze, because in the past we might have analyzed for 10 or 20 elements, but with all these elements that are increasingly important for us, we're analyzing for everything we can. And the cool thing is that about a year ago, we started to look at mine waste. And so we are funding projects to go out and sample mine waste to see what could be there. Another part of that is an inventory of mine waste. Here in the East, we don't think too much about mine waste except for maybe coal. But out West, there are huge piles. The stuff's already ground up. So could it potentially be reprocessed and get out critical minerals that we didn't know were there? So we can go to the next slide. So all the data that we're collecting can be seen through this data acquisitions viewer. And that's the website up at the top. So if you go to that site, you can see that map, and the different colors represent different kinds of data collection. And you can click on a state or a critical mineral or a type of data that we're collecting and see what's going on. So the projects really got off the ground in 2019. They're usually 3-year projects. Of course, we got interrupted by COVID, as everybody else did, but the data are starting to pour in. And it's really going to be a game changer in understanding where things are. And the cool thing is, in addition to looking for mineral resources, the same data, the geophysical data, helps us understand what's under the surface, where there could be faults and hazards, has implications for groundwater, energy resources, in addition to mineral resources. And so those little boxes are some of the recent press releases that have come out, because when we go to contract with a flight for aeromagnetic surveys, for example, those planes fly pretty low, and we don't want people to freak out when there's a low flying airplane. So anyway, you can see the data that's been produced if you go to the products in that page. And so there's a continuing release of data and publications to get the word out on where we might have critical minerals in the US. And I'd be happy to answer questions.
I will say you can either, it's up to the panelists if you'd rather like talk about minerals now and then move on, or do everything all at once and then do Q&A. So up to you guys.
I think we're gonna do Q&A at the end.
Yeah,
Okay.
I think that would be good. That way, make sure we can get through everybody.
Oh, I think this is mine. We all chipped in and put together slide sets. What I wanted to talk about is the greenhouse gas work that's going on at USGS. And before we focus on this slide, we've most recently been involved with the effort, this national strategy, and you may know about the National Greenhouse Gas Data Center that's run by NOAA, NIST, EPA, and NASA. And we've been working with that group and the White House for the last few years to put together a national strategy for coordinating measurements of greenhouse gas emissions across the United States. Our specific parts relate to natural systems emissions, that's wetlands and other areas that in the ecosystems that might produce greenhouse gas. And that's run in our ecosystems mission area. But the areas that we're focused on in the energy minerals group that I'm part of is looking at emissions from coal mines, that's active and abandoned coal mines. And we also are working with Interior on looking at emissions from orphan wells. And you might have heard about a large plugging program run by the Department of Interior, but we're working on helping to understand what are the emission offsets that result from those plugging activities. So another effort that we're going to talk about here that's shown on the slide is that I think it was in 2016, then Secretary of Interior asked us to USGS to put together an inventory of greenhouse gas emissions specifically for federal lands. The EPA does a national annual assessment of emissions, and every year for the total country. But the question that came to us, almost 10 years ago was how much of this emissions is related to federal activities, that is extraction of fossil fuels, the combustion of those fossil fuels, and then also how much sequestration that occurs simultaneously within the ecosystems and land cover areas that are also in federal land, because you have emissions and then you have, sinks that happen simultaneously. So we did first report in 2018, and this report that was released that you see on the screen was released just a few weeks ago. It's the 2024 update to the federal lands greenhouse gas emissions inventory. And what we found here, and you can, and there are references back to the older report, is that the emissions from federal lands, that is, all of the lands that primarily in the Western US emit on average about 22% of the national contribution of CO2 to the atmosphere. And that's resulting from fossil fuel extraction and combustion and transport and all the other things that are accounted for. About 6% of the methane from the national inventory that EPA reports comes from federal lands, and a little over 1% of nitrous oxides. And all of these are very potent greenhouse gases. So, and then we had data that go back to 2005, because the data sets that predate 2005 just were not capable of being put together to do these kinds of estimates. So 2005 is our start date. And then up to 2022, which is our most recent year that also parallels with EPA's report. We see that over that time period, about 17% reduction of CO2 emissions, a 38% reduction in methane, and then 30% reduction in nitrous oxide. And what this shows is that the EPA inventory also shows this as well, that overall the emissions are going down. And this is primarily related to fuel switching, less combustion of coal, and not mining as much coal in this country as we had in the past. So those emissions are going down. And what we also found was that on the federal lands, there's slightly more decrease of emissions on the federal land side. On the sequestration side, that is the uptake of carbon from these natural sinks. There's been a lot of variability over time, and that has influenced the amount of carbon that's being absorbed by the vegetation and the soils. But one of the largest impacts are the frequent occurrence of fires and wildfires. So when you have these large wildfire events, you offset that carbon uptake. So we're actually storing less carbon now than we were many years ago. And then what we found that only about 1.4% of the emissions that come from federal land fossil fuel extraction are then stored back into this land base that also is the federal footprint. And that's storing roughly 16 million metric tons of CO2 equivalent per year is what these natural systems store. And that's the URL of the report. Again, just a few weeks ago being live. And there's one more slide just to remind you where is this federal footprint that we're talking about. Largely in the western US, roughly a quarter of the land surface area is here, in the western US, it's federally managed land. We also include the federal offshore. There's red boxes out in the dots. Those are all producing, well, not producing, but oil and gas wells and facilities that are in the Gulf Coast and the Pacific Coast, and then in Alaska as well. So the emissions that I just talked about are mainly from those red areas and offshore boxes. So I'll leave it there and we can come back to this if anyone has questions. So. Thanks, Peter.
So this is me, and I was kind of redirected about what to talk about, but this is a talk I'll be presenting tomorrow. It's looking at national scale variability in groundwater levels, both in space and time. So that's one aspect of what I've been working on, and the next two slides are about this. But okay, okay. This was a group effort within the USGS, and we used available groundwater level data from wells throughout the US and looked at the duration of drought from 2001 to 2020, and also the severity. So basically, how many months within a year over that 20-year time period have these areas experienced drought? And severity is a measure of how depleted the water levels are. And so these illustrate the spatial variability, where you can see in the more arid regions of the US, the white and brown colors indicating more longer duration of drought, and then also more severe droughts as compared to the more humid areas of the US in the east. Next slide. And then we looked at temporal trends using both the observation wells. So we have about 1,500 observation wells, which really aren't that many wells. And you can see there are areas of the country that have a lot more wells available to use than others. So there are a lot of wells in the east compared to the west. So the map is showing these both, and so on the right, we use satellite-based data to try to compare. Well, here we looked at satellite-based data for the same trends in groundwater storage to see if the satellite data could provide more spatial information for the whole US. One takeaway, even just, so the dark colored triangles indicate statistically significant changes. The blues are a decrease in drought and the reds are an increase. You can see they don't really match up very well in terms of the colors. So we found, basically that the satellite-based data really can't substitute for the actual well observations. And there are several potential reasons for that, but that was a main outcome of that. Yeah, so should I talk about other? Yeah, okay. So, so other work that I don't have space for, but I've been heavily involved in geohealth studies, so looking at groundwater contaminants and the occurrence of them in groundwater used as drinking water, and so developing models to predict where arsenic and lithium occur in groundwater across the US. So we have wall-to-wall coverage of those predictions for the US. And those were developed in collaboration with public health scientists so that those models have been, and we're currently working on projects, they've been used to compare to human health outcomes. We've published a few studies on arsenic, and we're currently in the process of comparing lithium concentrations to health outcomes.
And that ties to the geology, right?
Yes, so the arsenic and lithium are from geologic materials in the aquifers.
And that's a component of, we do a lot of work on groundwater quality, surface water quality. Melissa's also done great work on impacts of, I think, drought
Right,
on arsenic. So you can actually see drought translating into arsenic, higher arsenic contents of waters. And it all comes back to the geology. So, and that's sort of a common theme that you're seeing so far is the role of geology in many different areas. And so next, thanks, Melissa.
Sure.
Next, Sarah.
Hi, everyone. You might be wondering, why is a social scientist here? What's happening to the USGS? Why are they bringing in social scientists? When Shake Alert was first, the idea was first floated and the concept was there, we really wanted to get the monitoring network right and the science right. And then for a few years, we really focused on that. And then over time, we realized as a science agency that we wanted to not only build a earthquake early warning system for the West Coast United States on the best physical science we had, but also on the best social science we had. Because when you start warning and providing warnings to people, we need to understand their experiences, how we can develop messages and information and protective actions that are reflective and important to them and that can reduce injury. And so in 2019, we formed the Social Science Working Group, which is a USGS, NSF, and academic partnership community of practice. So next slide, these are my co-chairs. But I want people to know that the USGS actually has been funding social science research in earthquakes for actually quite a long time, with the first one in Parkfield in the late 1970s and 1980s with Dennis Milletti, who was one of the founders of disaster research in my field. And then in 1989 in Loma Prieta and the Northridge earthquake also had funding and support from the USGS to understand humans' experiences around those earthquakes. Then we had the TriNet studies, which is sort of commonly known as proto
Shake Alert, this was the Southern California earthquake early warning system that was an experiment that also had social scientists involved in Kathleen Tierney and Kim Shove. And then we had the Great Shakeout. I'm sure many of you have heard the Great Shakeout scenario back in 2008 and the Hayward scenarios in 2016 that also had social scientists involved, like Dennis Maletti. Again, he came back to work with us. And then we had some work done in induced seismicity to understand that. And then we had early Earth Shake Alert projects, which were one-offs. And then we developed this social science working group model where we developed a research agenda. And we realized we had a lot of gaps in our knowledge and in the literature. There was no real comprehensive earthquake early warning studies around the human experience in all of its different flavors, like messaging, protective actions, all of those attributes until we started working on this social science working group. Next slide. And we have a code of conduct on how we work together as a team. We meet every month for about an hour, and we go from everything from what's the latest research, the state of the art research, to research ideas, to bringing in physical scientists to explain how all these things work. Next slide. So we have over 48 researchers involved, and we wanted to include, make sure it had a lot of diversity in terms of career ladders. We have named chairs and professors. We have early career researchers. We have graduates and undergraduate students are all involved. And we also wanted to make sure that we had a diversity of social scientists involved. So we wanted the anthropologists and the sociologists and the geographers and the social psychs, the operational decision science researchers, computer scientists, communication and media researchers like myself, science education researchers, emergency management researchers, building and civil engineers, public administrations. We even snuck a seismologist on the team for good luck. And it really was a transdisciplinary effort. And we now have 43 articles that we've produced, which represents one of the largest contributions to earthquake early warning and human experience that we've ever had. So through this 5-year process, we were able to fill so many of the gaps in our knowledge around how people understand, react, and respond to earthquakes and earthquake early warning. So our goals are to support social and behavioral science research that informs the operation and implementation of Shake Alert. We contribute to the USGS and global research community. So we have researchers from Mexico, we have researchers from Switzerland, we have researchers from New Zealand, Australia, all over the world who also contribute. So it's a global effort looking into this work. And we also support an internal group that focuses on communication, education, outreach, and technical engagement with Shake Alert. Next slide. And here's some of our resources. We have a whole publications page on shakealert.org that you can get to. And we also have a member space, a publication list, and a Zotero library if anyone is interested. Thank you.
And people know what Shake Alert is? You want to describe Shake Alert?
So Shake Alert is the earthquake early warning system for the West Coast United States. That's Washington, Oregon, and California. And we can alert up to 55 million people.
Great.
Yeah, I think that's it. I mean, we can have some questions or.
Yeah, let me just talk a little bit about some of the disciplines that aren't here. So we have a large contingent of ecologists, biologists, wildlife health folks. So we have a lot of work going on across the landscape, looking at ecosystems, animal migration, doing population counting or estimates of a variety of fish and wildlife, both within the US and in some cases internationally or in marine areas. We do a lot on vector-borne and zoonotic diseases through our National Wildlife Health Center and some of our other ecosystem science centers. And Peter mentioned the role of ecosystems and storing carbon, for example, and releasing carbon when that gets burned. So that it all ties back into what I talked about earlier, the Earth system. And we truly are a transdisciplinary Earth system science agency that brings in many different disciplines. And we also partner, as Melissa indicated, with folks in the public health realm as well to look at the impacts of the Earth system on human health. And also linkages between fish and wildlife health and human health and the Earth as well. So that's the main area that we don't have represented here today, but we have a lot going on there that we're happy to direct you to if you have interest. So with that, open it up for questions.
I have a quick one about the water. You said that the wells give you better data than the satellites. What satellites, for those?
So it's Grace satellite data, but it was compared to the DADM, which is, it's a drought monitor product that's based on the Grace data. So it's a model product based on satellite data.
Excuse me, a question. With the social science working group, you mentioned bringing in, a lot of folks from different disciplines and fields. I was just curious if there's an effort with that group to also reach out and, maybe bring in, get input from like emergency, managers and community leaders, city leaders, that sort of thing, in addition to the research community.
Yeah, absolutely. I went through my slides really fast. So our co-chair is Brian Turbush. He's with Washington Emergency Management Department for this very concept. And then we're part of a larger group called the Joint Communication, Education, Outreach, and Technical Engagement Committee, which is all about bringing in local, state, government, federal partners on that education outreach side of it so that we act as an interface. So absolutely. Thank you for that question.
Are the alerts issued? Are they mostly, you said you reach 55 million people?
Yes, so the alerts are issued, so we are an alert generator, and then they're distributed through distribution partners. And we have a variety, we can go to people's phones through the wireless emergency alert system that's run by FEMA. And that can send messages to smartphones and non-smartphones. We also have partners with apps. So we have a couple of app providers. And we also have alerts embedded into operating systems of mobile phones as well. So there's multiple ways. And then we have a whole group of technical partners that can provide on-site alerting for different organizations, companies, that kind of thing.
It seems like 55 seems a small number when you put it that way.
Well, 55 is the population of the West Coast United States.
Right.
So that's where the alert, so Shake Alert is active in Washington, Oregon, and California currently. That's where the monitoring system is.
Just a few days ago, we have 7.0 earthquake in California, and then there was a tsunami alert that was then canceled. Can you give us a brief overview of what you and your team did, and what sort of things that you were interested in terms of like how people reacted to the alert systems?
So we just run the Shake Alert system. We don't do the tsunami warning. That's NOAA, who is responsible through the National Tsunami Warning Center and the Pacific Tsunami Warning Center. So they're responsible for that. What we're really interested in is we just developed additional questions to the Did You Feel It questionnaire. So if you fill out a Did You Feel It form because you felt shaking, you can now answer questions on your experience with earthquake early warning. And right now we're analyzing that data to see how people responded to the alerts and warnings. One of the specific studies I didn't talk about, but this came out this year, is on the Ojai earthquake, which is a magnitude 5.1. And we were able to get 2,100 respondents on that questionnaire. And we found out how people responded getting that alert. So we were able to analyze that data, and we're just starting to crunch those numbers now and looking at that.
I have a question about the, go ahead. About the emissions, you said that 21.8% of the CO2 emissions were from production was from federal lands.
Yes.
So you're not talking about the CO2 that results from the use of that, just from the production.
No, it includes all of it, all of the production and use.
Oh, okay.
So we follow the EPA inventory methodology. For the most part, there are a few alterations that we have to do for federal land. But what we do is look at the amount, for example, of coal that's produced. And there is some emissions associated with coal production, so that's accounted for. Then you transport that coal, and the transportation emissions is accounted for, and then where that coal ends up, you know, whether it's going to a power plant or it's used for some, you know, coking facility at a steelmaking plant, all of those different uses are accounted for. And so it's combustion, transport, and then the production. And we also look at just say if any fuel, whether it's oil, gas, or coal, is produced from federal land, we track it to its end use and then do a full picture, you know, aggregation of all of the emissions associated with that. So we also, if it's exported, we count those emissions as exported combustion as well, which is a little bit different from what EPA does, but we were asked to task what happens to the fuels and what is the consequences of, say, mining, oil and gas production on federal land, and then how much emissions that this causes. And this is all used to make decisions about leasing or about future mining or whatever, but that's outside of our realm. We're just asked the question, how much emissions are associated with production of fossil fuel on federal land? I mean, and that's what we tried to do.
I'll ask one or two more. I was gonna go to the MRI, and I wasn't sure if you mentioned it, forgive me, but is there a sort of specified time frame for the mapping initiative, or is it kind of open-ended as far as?
Well, it kind of went into our base funding around 2019, 2020, but then we got a big push of $320 million for 5 years to accelerate our data collection. And so the last year of that money will be fiscal year 26. We just started fiscal year 25, but some of the work will continue in our base funding, as I understand it, for the mineral resources program.
And
Sorry.
and that big slug of money was through the bipartisan infrastructure law.
Yeah.
And I was just gonna say the Energy Act of 2020 also asked for
Right.
that within 10 years. So
Yes.
2030 would be the timing that would use all of the data.
Yeah, we're supposed to do a mineral resource assessment of all 50 critical minerals in that time period, which is a big job.
The key message is that the geology determines where the minerals will
Yes.
occur.
Yeah.
And so you have to understand the geology and go where the geology takes you to look at this. So looking at US, looking globally is a very important aspect of it.
So we understand from the geologic maps and from understanding mineral deposits and how they form, what kind of rocks are most likely to have those mineral deposits. And so then we devise these other kinds of data collection, look at the chemistry and look at the geophysical signatures, especially to help us see where there's things, as we call undercover. You know, there's a lot of stuff that's buried. You have a lot of part of the country that has glacial cover. There could be a really good deposit underneath it.
Could you talk a little bit about what the some of the other things that the data you're collecting work for besides just critical minerals?
Well, anything that we collect with the geophysical data is telling us about the subsurface, so it can help us understand where there are faults. The other thing I don't think I mentioned is the LiDAR data. LiDAR is really cool. It's a light ranging something, LiDAR.
Light
ranging.
Ranging.
Yeah, light detection and ranging, that's what the D is. So it's pulse lasers that can actually give us really detailed topographic maps of the surface. And what's cool is it can see through vegetation. So if we're looking for maybe like ancient beach terraces, or we're looking for pits that, you know, we're out in the woods now, we can see that. So our 3-depth program is got 98% coverage of the whole country with LiDAR data. So the best thing is if we send somebody out to do a geologic map and they've got the detailed topographic information, they have the geophysical information that can help them, you know, determine where to go to look for things that are really interesting.
Are there challenges with navigating private ownership in that mapping project?
We're very careful. Anybody who goes out and does mapping, make sure we have permission to access the land in any of our sample collection. And we also do mapping on federal lands. but we're in concert with Forest Service and Bureau of Land Management and anything to do with any tribal nations. There's very systematic information that gets passed along.
Are you also working with mining companies then, or?
Not per se, although we have had mining companies who are interested in the geophysical data. And so the data we collect are for anybody to use, for the public. And there are special cases where there might be partnerships with mining companies. To example, look at some of these critical minerals that are in their processing or in their mine waste. There have been a few projects like that, but in general, we don't, that's private industry.
And a couple of other things too. Jane mentioned faults, so there's a very
Oh,
clear
yeah.
application to hazards, and there
Right.
was a study that came out looking at the mineral resources along the coastal plain in the southeast, but also happened to cover Charleston, which is
Oh,
a
right.
seismically high area from past faults, and they could actually see some very good indications through the three-dimensional geophysical data showing into the subsurface that they could help interpret where the faults were that were actually potentially contributing to the seismicity. And there's also data that we can be collecting that will help with water resource estimation, looking at groundwater. And we're also collecting radiometric data as well, that can provide a variety of types of information.
Yeah. Which leads into like telling you where radon might be coming from.
Yes.
In the rocks.
And other applications and areas that I'm involved with, the deep image or geophysics can identify faults, as Jeff was talking about, but it's very important in the geologic sequestration area where you're putting CO2 in the subsurface, really to know where these deep faults occur. So the type of geophysical data that is being collected with Earth MRI can be applied there. Plus, there are applications where it can be used to help identify orphan wells that maybe had been lost. Steel that was related to those wells in the ground shows up on the geophysics.
Right.
So there may be a well out there that we never knew about
Right.
that has been long covered that shows up in the deep geophysics. So there are many applications to this.
This is a phenomenal big data collection set that is generational. I've heard it called. This is
Right.
a massive investment, helping understand what's beneath our feet. And I always like to say geology is the bedrock of so much Earth system science. It ties to hydrology,
Right.
it ties to hazards, it ties to geology and the soils that underlie ecosystems. And it plays a role as Melissa's work and others work on human health implications as well.
A
So
lot of other countries have really good geophysical data and detailed geologic maps, like Canada and Australia. We're trying to catch up. We want to have data that's as good as theirs or better.
Don't show Alaska on this.
Yeah, it's on the lower.
Oh, there it is.
It's south, I'm sorry.
My bad.
I couldn't put it on the page.
My glasses back on.
Yeah. No, there's a ton in Alaska.
I bet.
Yeah. And the cool thing about Alaska is, there's a lot of unknown territory. And so for these 23 different mineral systems, there's a lot of overlapping mineral systems. So that's why we targeted an area in sort of central eastern Alaska called the Yukon-Tanana area. We targeted that as the first place we were going to collect a lot of data because there's potential for so many different things there.
in terms of mineral resource development, the geology also plays a role in helping understand what might the environmental implications
Right.
would be, so that they can be prevented rather than remediated. And also being able to help provide insights into how to better clean up things like past historical tailings piles or mine waste piles or things like that. But the great thing is, do these new critical minerals that weren't looked for in the historical mining, can those be used to help offset costs for cleanup as well?
Right.
Any other questions before we wrap up?
Also, you mentioned a study of connections between public health and arsenic levels. Were there any major takeaways from that study?
So we've done a few different ones. One was looking at birth impacts, so low birth weights and gestational age. And that study was led by Catherine Bulka, and I think it was published in 2002 or 2022. She found slightly lower birth weights, about on average 3 grams, with higher arsenic concentrations, but we're actually still looking at quite low, relatively, so low arsenic levels. The drinking water standard is 10 parts per billion, so that was the cutoff for the higher level of arsenic. So a goal is to see if we can see health impacts at these lower concentrations, which are more typical in the US. We do have some areas that have much higher levels, but another study looked at so using human health cohorts. So NHANES is a big one where it's a national, they recruit people in these national health studies and collect information from them about, where do they drink their water, where do they get their water from, what kind of diets do they have. And then they also collect blood and urine samples. So we compared urinary arsenic to drinking water arsenic and did see that there was a correlation there. So there's body burden from the drinking water. There's another study led by Maya Spar. So she did the NHANES study, and then a second one was looking at diabetes occurrence and 2 other health cohorts, a MESA and Strong Heart Health study. And again, did see a small increase in diabetes, onset of type 2 diabetes with higher arsenic concentrations.
And like Melissa said, we don't do the public health work. We always partner with collaborators from outside,
Right.
from the public health, and that's been a great area of collaboration. When you bring in our wildlife health people who are looking at things like avian influenza and West Nile virus and other wildlife diseases and how those link to human health, it's a pretty cool package of what the USGS can bring to bear from a natural environment and the earth system and how it links to human health and fish and wildlife health.
Okay, we are a touch over time, but thank you to our panelists and everyone who came. We'll wrap up there. This was a great, interesting conversation, I think. Our last press conference for journalists today is at 3:30. We have a workshop from National Geographic on some of their water maps and water data. So dive on in. Thank you.
Thanks for coming. We appreciate it.
Thank you.
Yeah.